Hello everyone and welcome back to the channel. So today we are going to discuss yet another problem on maps, and we are discussing Leetcode problem 560, subarray sum equals k. So let's quickly go through the problem statement. The problem states that given an array of integers nums and an integer k, return the total number of subarrays whose sum equals to k. So the very first obvious approach that comes to our mind is the brute force approach. Let's quickly discuss the brute force approach for this problem. So the brute force approach is going to be that we can check each subarray individually, and we can keep a counter and keep increasing it by 1 whenever the sum of the subarray is k. So what would be the time complexity for this solution? The time complexity for this solution is going to be big O of n square. How can we prove this? So we know that there are going to be n subarrays of size 1, and then there are going to be n minus 1 subarrays of size 2, then n minus 2 different subarrays of size 3, until the point that we have only one subarray of size n, and this subarray is actually same as the complete array. So the total subarrays that we have is actually n plus n minus 1 plus n minus 2 plus n minus 3 till plus 1. Now we know that the sum of this series is equal to n into n plus 1 by 2. And we can see that this sum, this final answer, is actually of the order of n square. So if we are processing each subarray individually, it is definitely going to take time big O of n square. Now for instance, if we need to compute the sum of all subarrays of size 3, so let's take an example array. So our array is A, B, C, D, E, F, and we need to compute the size of all subarrays of size 3. So our first subarray is going to be from A to C, and we can easily find the sum as A plus B plus C. Now when we need to find the sum of our next subarray, which is going to be from B to D, we can do it in O1 time. So how can we do it? We have to simply add the element being pointed by the right pointer, that is D, and we have to subtract the element which was being pointed by the left pointer previously, which is A, and move the left pointer by 1. Now similarly, when we have to find the sum of the next subarray, we can again do it in a very optimized manner. So the next subarray is going to be from C to E. We again need to add the element being pointed by the right pointer E, and we need to remove the element previously being pointed by the left pointer, that is B, and move the left pointer by 1. Now we can see that the sum for each subarray is actually calculated in O1 time, and with total n square subarrays, the time complexity or the overall time complexity for the complete solution is also big O of n square. But we can see that n can be equal to 2 into 10 raised to power 4 as specified in the constraints, which implies that n square complexity is actually not going to work in the worst case. So we need to think of a better approach. So now we'll discuss a better approach, and let's try to understand this approach very carefully, as this approach comes in handy in a variety of questions. So let's take a sequence of numbers, and let's say that the numbers that we have taken are A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. Now let's say that the sum of the numbers from A to C, that is A plus B plus C, is X, and sum of the sequence from A to H is actually X plus K. So this is the sum X, and sum of all these numbers from A to H is actually X plus K. Now then, what is the sum of the numbers between C and H? And obviously the sum of the numbers between C and H is going to be K, which is X plus K minus X. Now let's say that the sum of all the numbers till k again is x plus k somehow. So we are saying that from starting till k, or the sum of all these elements is actually x plus k. Now then what is the sum of the numbers between c and k again? So again the sum of all the elements between c and k is going to be k, which is again x plus k minus x. And here we can derive one more conclusion, that the sum of the numbers between h and k is actually 0. Now let's assume one more case, and let's say that the sum of all these elements is actually x plus 2k. So from here we can say that the sum of the elements between h and o is actually going to be k, and the sum of elements between k and o is also going to be k. Now if we have understood this logic, we can actually rephrase it and say that if the sum till a particular point is x, then if we know the occurrences of x minus k till now, then the sum between the current position and all the occurrences of x minus k is going to be k. So to find the subarrays having some k and ending at the current position, so the current position could be anywhere where we are currently standing in the array. So if we need to find out all the subarrays having some k and ending at the correct position, I just need to store the frequency of sum x minus k till now. So all the points where previously I would have got the sum as x minus k, all the elements between that point and my current position are actually going to have sum equal to k. So this is the whole logic of this problem. We traverse the array and keep finding the sum till that particular point, and we keep storing the frequency of each sum we have got till now. Now if the current sum is x and we had y occurrences of x minus k till now, then we definitely have y subarrays with sum k. And since we are keeping track of frequency and we need a data structure that can insert elements and search elements in the most optimal manner, we obviously use maps for tracking this frequency. Now one additional case is that the sum at any point becomes k. So let's say if the sum till here is actually k, all these numbers add up to k. So we can simply increase the answer by 1 because this is one subarray which is going to have sum equal to k. So let's quickly dry run on an example. So we'll take one of the examples only. Let's take 1 comma 2 comma 3 and our k is equal to 3, and this is going to represent the map. So here I am going to store the sum and here I am going to store the frequency. So at the first point the sum is actually equal to 1 and the frequency of 1 is also 1, and we do not have 1 minus 3 in our map, so answer still remains 0. Now we move at 2 and the sum becomes 3. So we'll add 3 into the map and we'll add the frequency as 1. But we know that we have actually found one subarray whose sum is equal to 3. So we can increase the answer by 1 and answer will become 1. Now again I will move to the next point, and here my sum becomes 3 plus 3. So this sum becomes 6. Now I go into the map and I look for 6 minus k, which is 6 minus 3, and I look for 3. Now we have actually seen, or we have actually got 3 in the past, and the frequency with which we have got 3 is 1. So we have only got 3 once. So we will increase the answer by this frequency because all these subarrays starting from the point where we got 3 till the point where we have got 6 are actually going to have a sum equal to 3. So the answer now becomes 1 plus the frequency of 3. So the answer becomes 2. So now we have completely traversed the array and our final answer is 2. So let's quickly go through the working code for this solution. Now this is the main method that is going to be called, and this method is going to return the number of subarrays having some k, and this is the array or the vector, and obviously we have a input variable k. Now we have declared an unordered map, and as we have discussed, the map is going to store the sum that we have got till now and the frequency, the number of occurrences of this sum till now. And we have also initialized our variable sum, which is going to store the sum till now, and the final answer variable, which is going to store the number of subarrays. Now, as we discussed, we traverse the complete array and we pick elements one by one. So when we are picking elements one by one, we actually add the element to the current sum. So because sum stores the actual sum of the array till now. Now if this sum is equal to k, as we have discussed, this is the case when we have actually found one subarray starting from 0th position till the current position, which has sum equal to k. So we simply increase the answer by 1. Other than that, we try to find that if we have actually seen a sum minus k in the past. If we have actually seen sum minus k in the past, from the point where we saw sum minus k till the current point, the sum of all the elements is actually going to be k. So the occurrences of sum minus k ensures that there are going to be subarrays which are going to have sum equal to k, and the frequency of sum minus k, so the number of times or the number of occurrences of sum minus k is going to be equal to the number of subarrays that are going to have sum equal to k. So we simply add the frequency or the occurrences of sum minus k to our answer, because that is the number of subarrays which are going to have sum equal to k for sure. And then simply we increase the frequency of current sum. So we have seen the current sum once, so we add it. So in the map, we increase the frequency of current sum by 1. And once we are done with this loop, we'll actually have the total number of subarrays, and in the end we do nothing, just return the final answer. Now finally we can discuss the time complexity. So we are traversing the complete array 1. So this is the loop in which we are doing that traversal, and at each point or in each iteration we are actually doing a insert, search, or a update in map. But all these operations, insertion, searching, and updation in a map, are actually O1 operations. So the complexity for the solution is complexity of linearly parsing the array. So the overall complexity for this solution is big O of n, because we are picking each element one by one. Now we can see that we have actually improved the complexity from n square, which was for brute force, to n by using our map. Now I hope you understood the logic, and it will become more clear with practice definitely. And as I said, it is a widely used approach and you will find multiple questions on it. We will also solve one more question on this approach in the next video, but as a homework you can try this particular problem. So the problem says that given a binary array, find the number of subarrays with equal number of ones and zeros. So if you will try to search it on Google, it's a very famous problem and you'll definitely get a Leetcode and Geeks for Geeks link. So you can try to practice this question. It uses the same approach. Now with that, we can end this video here. So see you in the next video. Take care and goodbye.